12.3 measures of dispersion. We're going to talk about standard deviation in this video, and all we're going to do is figure out how to calculate the standard deviation. 12.4 will actually use the standard deviation when we study the normal distribution. It's probably good that you calculate a few of these. It gives it more meaning. Well, first of all, we have 6 scores, 20, 20, 40, 40, 60, 60. This could be scores on exams. This column X sub I, this is just a way of subscripting the scores. This would be, for instance, X sub 1. This would be X subscript 2, X subscript 3, X subscript 4, X5, X6. You can't just say X equals X equals X equals X equals, so we subscript the variables because these take on different values possibly. It's good to get used to that indexing because it shows up a lot in statistics. Now, second of all, this is just simply the deviation from the mean. So we have 20 is, I already calculated the mean, add them up, divide by 6, and we get 40, 240 over 6, and 40 makes sense. 40 is right in the middle here. 20 minus 40 is negative 20, and we get negative 20 for this one as well. 40 minus 40 is 0. That's the deviation for this one, and 0. 60 minus 40 is 20, and we get 20. As we did before, you can add all these up. Negative 20, 0, 0, 20, 20. It adds up to 0. You can add it up and get 0 just to check. Now this is the deviation squared. Whenever you square a number, the answer is positive, so this negative is going to go away. 20 squared is really negative 20 squared is 400. And negative 20 squared is 400. 0 squared is 0. 0 squared is 0. 20 squared is 400. 20 squared is 400. Now what we're going to do is add this up. 400 plus 400 plus 400 plus 400. Well, 4 and 4 and 4 and 4 is 16, so we get 1600. That's actually the sum of the squares of the deviations. Then what we're going to do, n is equal to the number of scores, which is equal to 6. N minus 1 is 6 minus 1, or 5. That's always 1 less than it. This is the procedure to calculate the standard deviation. I'll show you the formula in a minute. Then what we're going to do is divide 1600 divided by 5, and then that ends up being 320. And you can use a calculator for that if you want. And then we're going to figure out square root of 320 is 17.9 rounded. It's 17.38 and a 5. That is actually equal the standard deviation. The formula for it is S equals square root sum x sub I minus x bar squared. I goes from 1 to n, all divided by n minus 1. Looks very complicated, but this is actually just the sum of the squares of the deviation. That's just this column right here. Divide by n minus 1, 1 less than the number of scores, and then take the square root. And that's all we did. On your homework, feel free to make a table like this, even if you don't label the tops, no one will know. But you need to figure out the deviations, square the deviations, make sure these are all positive. If there's any question, use a calculator, 20 times 20, 20 times 20. If these are decimal numbers, of course, the computations are more complicated. Feel free to use a calculator. Go through this process. One less than the number of scores, divide it into this, 320, and then take the square root of that. That gives you that number. And round to whatever place they tell you in the homework. So this is very, very useful for something called a normal distribution. Normal distribution is central to statistics. You use it an awful lot. In here we'll have an introduction to it. There are an awful lot of statistics that are normally distributed about a mean. And of course, the standard deviation tells us something significant about how the distribution falls for a given statistic. So it's an extremely useful measure of dispersion. This also gives you a good measure, good aggregate measure. Everything gets a vote. So anytime something deviates from the mean, when we square it, it adds to this total right here. So if things are very spread out, this number is high. If things are very concentrated in the center, this number is very low. Even if you can have a high range with everything concentrated at the center, and this could be a very, very small number. On the other hand, if everything's out here at the extremes, then this aggregate sum here is going to be very large. So just one more thing. There is something called a box and whisker plot. And this is just a way of grouping the data, giving a graphical representation of grouped data. And what this represents is, this is the tens place, this is the ones place. The scores are really 11, a 1 and a 1 is another 11, and a 1 and a 2 is 12, 12, 15, and then down here 20, 21, 22, 22, 23. So if you have a box and whisker plot, you need to calculate the standard deviation. Just write out the scores and then figure it out that way. And then you could figure out the mean. You'd have to add it up, divide by however many scores, in this case 10. Set up the chart with the deviations, square the deviations, add it up, etc., etc. That's how you do it. This is an interesting way. It's kind of like a frequency distribution. If you had 10s, 20s, 30s, 40s, and 50s, you could pick out visually where most of the scores are based on how long this whisker tally is. So if it were this, for instance, then you can just tell there are more numbers in the teens than there are in the 20s, just based on how wide this record is here. So it's an interesting way to visualize how the data is distributed. So, okay, that's all for this video.